Okay, in this problem, so how many solutions does it have? It has two real solutions. Here's one. Here's the other. And I'm going to say that that one is negative 1, 0. That's pretty easy to say. And this one, let's just say it's 1.5 and 0. And then I have two real solutions because it's hitting the x-axis twice. All right, next page. So here's another system, and you need to either use substitution or elimination. Either would work great. Since we've already done substitution, I'm going to do the elimination on this one, which means I need to get everything to line up. So I'm going to bring these things, 16x and negative y, over to the left side. So it's going to be x squared minus 16x plus 66 equals the negative y. I'm going to leave that over here on the right side. And then I'm going to take this one and move the 18 over and move the y over to the right side. So my 2x lines up with this. My 18, which is now subtracting 18, lines up with 66, and I'm going to add y to the other side so these line up. Now this would have been great to do as the substitution method as well. So whichever you prefer. But anyway, in the elimination method, what happens is when I add up these y's, and you always want to eliminate the y's first, cancel out, and then I'll add the x squared down, add the x's, there's negative 14x, and then I'm going to add the 66 and the negative 18, which gives me 48. And now when I'm ready to solve, I see that I have more than one type of x. That means I should try to factor first. So I need factors of 48 that get me to negative 14, and that would be a 6 and an 8, both of them being negative. So when I multiply that, I get to 48, and when I add them, I get to negative 14. And then I can go straight into my parentheses, because this is easy factoring. And now I just need to ask myself what's going to make those factors 0. So one of them is 6, and the other one is 8, which means if I graph this, this is a parabola. This one is a line that's going like this, and it's meeting twice because I have two solutions. And right now, one of the solutions is negative 8, and I have to find its y-coordinate, and the other one is 6, and I have to find its y-coordinate. So the easiest way to do that is to take these values for x and substitute them into either this one, but I'm actually going to substitute it into this one. That seems to me to be the easiest one. So let's start with the negative 8. So I'm going to take 2, and in for x I'm going to put a negative 8, and then I'm going to subtract 18. This will give me negative 16, and then when I subtract 18, I'm going to get negative 34. So there's one answer. And then I'm going to put the 6 in, and when I put the 6 in, 2 times 6 is 12. Take away 18, and I'm going to get negative 6. So there's my y answer. All right, that's 14. Moving on to 15. All right, here's the function. So this is a word problem, and we're asking you to use your calculator, but I'm going to show you how you can not use your calculator as well. But first with the calculator, I'm going to be going to the y equals button, just so you know. And I want to make sure that all my plots are off. All right. So we've got this function. It's the height of a football, where h is the height and t is time in seconds after it's kicked. And so if you can see, this is a parabola because of the squared, and it's an upside down parabola because of the negative, and that's the path a football being kicked would make. And we're going to use our calculator to answer it. So when will the football hit the ground? So from here, where it starts, to here where it hits the ground. And the idea, this is the x-axis. So on the calculator, I'm just going to type this in. And then I'm going to hit zoom 6 for a standard window. And it's going up and then coming back down, so it's hitting the x-axis here. Now that looks like 3, and it's a 0, but if you're not sure, remember, use second trace to go to the calc option. We're going to go for 0, number 2, and I just need to trap this, on the, okay, it's coming back down. I can see that because I'm looking at the y's. Above it, and then below it, and it's 3 because this value is just, that's pretty much 0. So it's going to hit the football after 3 seconds. How high is the football? Well, that means I need to see the vertex, which is way up here. So what I need to do is I'm going to go to zoom, and this time I'm going to go to 0, which is fit, and hopefully, I'll be able to see it a little bit better. That's my first option. All right, and it's a little bit up there. I'm going to adjust the window. I'm going to press the window button, and I want the Y max to go a little bit higher, so I'm just going to change it to 50 and then hit graph. And maybe a little bit more. Let's make it 70. All right, so there's the top. So I just needed to use the second trace again for the calc option. I'm going to choose maximum, and I got to trap it somewhere on the left. So there's somewhere on the left, somewhere on the right. Hit enter, and X is about 1.47, and the height is 37.5. So how high is the football? Oh, sorry, I just answered this one. What's the maximum height? That's the Y answer. That's about 37.5 feet. Let's go to B. How high is the football after 1 second? Probably the easiest way to do this is go to your table and find where X is 1. So if your table is starting at this value like mine, press the second window to go to table set, and I'm going to have my table start at 1. And you want to make sure that both of these are highlighted. So I'll go back to the table, and when X is 1, it's 34 feet high. And write an equality that represents when the football is at least 30 feet high. So I want this inequality to be at least 30 feet high. So I'm looking for, and there is no E, when this, and this, remember, this is all H, when this height is at least 30 feet high, if not more. So I want my height, I want this height to be at least 30 feet, if not more. So I want it to be greater. So this amount, my height has to be greater than that. So that's how I would write that one. Now, without a calculator, when will the football hit the ground? I would probably do the quadratic formula on this because I would be solving for X. So I would use the quadratic formula, solve for X, and then you'll probably get a positive and a negative answer, and you would want to be going for the positive answer because time isn't negative. How high is the football after 1 second? I would just find out when T is 1 and put 1 into here, and you'll get the 34 amount. And then what's the maximum height? I would just find the vertex. So at first I would take the opposite of B over 2A, get that value for X, plug it back in to get for Y. So the graphing calculator will definitely speed this up, right? All right, next one. The aspect ratio of a wide screen TV is the ratio of the screen's width to its height. So the width to its height. Or 16:9. What are the width and the height of a 32-inch widescreen TV? Justify your answer. So basically what we're going to do is we're going to use the Pythagorean theorem and the fact that the TV sizes refer to the diagonal length. All right? So what they've done is they've already put this in here, and the width and the height, and then here's that. When they measure the TV, they measure from diagonal to diagonal. So I just have to figure out the actual width and height. So I'm going to use Pythagorean theorem. So it's going to go 16x squared plus 9x squared equals 32 squared. And now my job is to solve for x. And when I look at this, I have the same type of x. Here I just have 16 of them. Here I have 9 of them. So I'm going to add them up. 32 squared is 1,024. Now to solve for x, I'm going to divide by 25. And that's going to give me this lovely decimal. And then to solve for x, I'm going to take the square root, and I'm going to get the square root. Remember, it's going to be a positive and negative number. And I'm going to get 6.4. Now, in this problem, I'm only going to use the positive value because length and width can't be negative. So I'm just going to use the fact that x is 6.4, and now I'm going to put 6.4 into this one, and 6.4 into this one. So when I take it times 16, I get this. And when I take 6.4 times 9, I get this. So here's my width. And what was this, in inches, I think? And then here's my height in inches. All right, next one. So we're going to solve this system by graphing. And let me grab a graph for this. I don't have one. Pardon me. Yours has a graph, mine doesn't. Sorry. Okay, let's put this on here. So first one I'm going to solve, I'm going to do one at a time, and when I graph them, remember inequalities mean we're going to shade, and they're going to both be dashed lines because of this. So let's start with this one, standard form. So standard form to find the vertex for x, you got to take the opposite of b over 2a. So here there is no b. If I have to add a b, I'd add a 0x. So the opposite of b is 0, divided by 2 times a is a fourth. Whoops, and that's just going to give me 0. So my x-coordinate is 0. And to find the y-coordinate, I just plug 0 back in here. And 0 squared is 0, 0 times a fourth is 0, 0 minus 2 is negative 2. So for my first one, my vertex is 0, negative 2, which is here. And now I'm going to use my one-time slope of a fourth, and that's, I mean, going up a fourth and over 1, that's going to be pretty tough. So just know that this is going to be a really wide U when you graph it. So sorry, and I should be doing this with a dashed line. I'll fix that here. Imagine this is dashed. Okay. And now I want to see, should I shade in the U or outside the U? And so I'm going to test this point 0, 0 because it's not on the U. So if I test 0, 0 into my problem up here, I get 0 on the left. And when I put 0 in here, we already did that. 0 squared is 0, times a fourth is 0. Take away 2 is negative 2. Is this true? And that's true. So that means all the points inside of here would work. Any x and y coordinate would make that inequality be true. And now I'm going to graph the other one. This is vertex form. So if I just look at it, my vertex is opposite of this, or what makes it 0, negative 3, 4. So negative 3. And this one's upside down because a is negative 1. So I'm going to use my one-time slope. And I'm going to graph this one. This is more, whoops, and this should be dashed too, sorry. Should be dashed all the way through. And now I want to test to see, does 0, 0 work? And I can test that one, again, because it's not in my U, it's outside of my U, or it's not on the U. So I'm going to test 0, 0, and 0 on the left. And I'm going to put 0 in for here. So if I did that, 0 plus 3 is 3, 3 squared is 9, and then that 9 is going to become negative. And then from all of this, negative 9 plus 4 is negative 5. So again, this is all I did. So I got 3. 3 squared is 9. Then negative came with it. I added 4, and I got the negative 5. Now, this is not true. 0 is not less than negative 5. 0 is bigger than negative 5. So for this one, I wouldn't shade outside the U where the x is. I would shade inside the U. And then let me reshade this one a little more. Because now, when I shade inside the U here, the area that's shaded twice, this is my final shaded area. And you really want to make that stand on the test. So any point in this section, if I took those x and y coordinates and put them into both of them, would make this problem work. Okay, last part. So I just want to put a little bit more graphing on there and one of each form. So you're going to graph them, and when you do, I want you to state the vertex, what's your A, and describe the shape. So I'm going to start with the shape. The fact that my A is negative 2 means this is going to be upside down, and it's going to be skinnier. And again, in your notes, this is page 26 in your notebook, this is factored form, which means I'm going to use the factors to see where my graph hits the x-axis. So I just need to ask myself, what's going to make my factors be 0? So in this one, x equals 3. And in this one, x equals -1. Now from there, my vertex is in the middle. So what I could do is just work my way to the middle and see. But if you don't know that, what you do is you just take those numbers that we just graphed, which is the 3 and the -1. You add them up, and you divide by 2. So this is to find the vertex. And I'll get 2 on the top, and 2 divided by 2, I'm going to get x to be 1. So my vertex is here, and then I know it's going to be up here because when I draw this, it's got to be upside down. So to find the y-coordinate, I'm just going to plug this x back in. So this is all I'm doing. Here's the -2. I'm putting 1 minus 3 and 1 plus 1. Moving up here, that's just -2. 1 minus 3 is -2. And then 1 plus 1 is 2. So when I multiply -2 and -2, that's 4. 4 times 2 is 8. So my y-coordinate is 8. So I can just go to 1, 8. That's great. I've got enough points. If I really want to, I can use my one-time slope of 2 over 1 and go down 2 and to the left and right 1 to graph my u. Something like that. All right, next one. This is in standard form. We've already done this a couple times. But to find the x-coordinate, I'm going to take the opposite of b, which is 8, and I'm going to divide it by 2 times a, which is -2. This becomes 8 over -4, and that is -2. So this is my x-coordinate for my vertex. And to find the y-coordinate, I'm just going to plug that -2 back in. I'm going to make that plus -8 and plus -5. All right, so again, you could type this in your calculator. I want you guys to see this without that. The idea is in here, I'm going to find out what that's worth, so I can put it with the -5. I'm going to do my exponent first. When I square -2 times -2, that's 4. And then 4 times -2 is -8. And then I'm going to multiply those two, and I'm going to get a positive 16. And then I'm going to add the -5. And when I add those up, I end up y to be 3. So my x-coordinate is -2, my y-coordinate is 3. And so there's my vertex. Let's see. And then I'm going to use my one-time slope of a to go down 2 and over 1. Now this is another problem. I also have another easy point to graph if I want to get it, and that's the y-intercept, which is -5. It's always c in standard form. And then what I could do is get its partner point and actually end up with a pretty good parabola. Okay. And then here, I never actually stated the vertex. I should do that. And that vertex was 1, 8. Last problem. This is vertex form because when you look at it, you see the vertex. So the vertex is what makes that 0, which is 3, and then k as is. So here's my vertex, 3, 1. My a is 2, which means it's going to be a regular u, and it's going to be skinny, which I realize I did not talk about that up here, that it was a was -2 upside down and skinny. All right, I'm going to have to backtrack on this problem because I had to stop and I'm not sure where I left off. So this problem's in vertex form. We said that a was 2, which means it's a regular u, it's going to be skinny. And then we found the vertex. What makes that 0, 3, is your x-coordinate, and what makes that y, 1, is your y-coordinate. And so I've got my vertex graphed, and now I'm going to use my one-time slope of 2 over 1 to get my other points. So from here I'm going to go up 2 and over 1. And then I will graph my u. All right, last problem. You're going to solve the inequality algebraically. And again, when you have one variable, your solutions go on a number line. When you have two variables, x and y, with the inequality sign, then your answers go on a graph. But so when we're done solving this, we're going to be showing our solutions here. So what I want to do, since there's more than one type of x, I can factor or do the quadratic formula. This will be able to factor though. So 1 times 8. Factors of 8 that add up to 6 would be 2 and 4. So I can go straight into my parentheses. This is easy factoring, x plus 2 and x plus 4. And I'm just going to put an equal 0 here for now. And what makes this one 0 is -2, and what makes this one 0 is -4. So those go on my number line. And now what I need to do is test a point. And the easiest point to test is 0, 0. So x being 0. But you can actually test a point in all three sections if you're more comfortable. But your solution's either going to be between these two or it's going to be outside the two. Just like if you graph, it's either going to be inside the U or outside the U. So if you imagined your parabola being graphed here, I'll draw this very lightly, we're either shading in between or outside of the U. So I'm going to test 0, which is outside the U, and I'm going to put 0 in for x. So I already have that. And I'm going to have 0 squared plus 6 times 0 plus 8. And then I get 0, here's another 0, add 8, and now I just want to ask myself if that's true. And that's not true. That means I wouldn't shade outside the U, I would shade inside the U on this number line. Okay? And so what I'm saying is the solutions that's going to make this work is the fact that x is in between -4 and -2. And the way to write between in an inequality, because you can write it as an inequality, and I'm going to have underlined here because it's underlined here, is my answer is between -4 and -2. This is something covered in Algebra 1. Or I could write it as an interval notation, which means I'll use brackets since it's equal to -4 and -2. And that's it. That's the review.